In these tutorials, I am going to explain to you how to calculate overhead absorption rate using different activity bases. If you will find this tutorial very helpful, please consider subscribing to this channel and turn on your notification bell. Let's go straight to the question. The question on your left states the allocated and the apportioned overhead cost of production department X are 24,000 during a period when the department produces the following units of products. You have product A, B, and C and the associated data with it. The question was quite specific that we should use direct labor hours basis, but we are going to use different approaches. So, in order to calculate your overhead absorption rate, you have to use the formula total overheads as calculated or given divided by the total activity base. The total activity base can vary according to every question, but the most predominant one that are given in any question is the total labor hours, total machine hours, total labor cost, total prime cost, and total units produced. Okay, now let's use total labor cost or total labor hours as the first approach, and let's calculate the overhead absorption rate. Now, the total overhead given is 24,000 as stated in the question. Right? Now, what is the total labor hours? In order to get your total labor hours per every product, you have to look at your labor hours per unit multiplied by the units produced. So for product A is 3,000 units, product B is 4,000 units, and for product C is 1,000 units. Now, when you multiply the 3,000 units by 0.1, which is the direct labor hours per unit, we get 300 hours. Likewise, 400 units by 0.2 and 1,000 units by 0.1. We'll get 800 and 400 hours for B and C respectively. So the total overheads will be 1,500 hours. The overhead absorption rate using total labor hours will be 24,000 divided by 1,500 hours, giving us $16 per labor hour. Let's switch to the right and use machine hours. Now, the same approach is what we are going to use because the total overhead given in the question is 24,000, right? But the question states that the machine hours per unit is 0.2 for A, 0.1 for B, and 0.2 for C. What is the associated units produced? For A is 3,000, for B is 4,000, and for C is 1,000. So the total machine hours will be 3,000 units by 0.2 hours for A, 4,000 units by 0.1 for B, and 1,000 units times 0.2 for C. The total will be 600 plus 400 plus 200, giving us 1,200 machine hours. The overhead absorption rate is going to be 24,000 divided by 1,200 hours, giving us $20 per machine hour. Let's use the total labor cost. In the question, we've seen that the direct labor cost per product is 3,500 for A, 8,000 for B, and 4,500 for C. So when we add 3,500, 8,000, and 4,500, we get $16,000 as the total labor cost. The overhead absorption rate will be 24,000 as given in the question by $16,000, giving us $1.5 per labor cost. Let's go to the prime cost. The prime cost given in the question per unit is 3, 4, and 5, right? Great. Now, if we want the total prime cost, then let's multiply the prime cost per unit by the units produced. We are going to get 30,000. So the overhead absorption rate is going to be 24,000 divided by the total prime cost, giving us $0.8 per the prime cost. Now, if you have understood what I have explained so far, then calculate the overhead absorption rate using the total units produced. You should arrive at an answer of $3 per unit. Thank you, and subscribe to the channel.